Alright, for today's Python project, we are going to be recreating the classic game Snake because, well, given the name, I think it fits perfectly, especially given we are going to be using the Pygame library that also has, well, a snake as the mascot. Now, I don't think I have to explain this game to anyone because probably even those who, for some reason, for whatever reason, don't know this game, I think by now have understood how it works. Well, our game or our version is not gonna look as polished as this because that has like really multiple game modes and all. I really remember playing this in school. We even had like a leaderboard and all. We were all playing it during classes. Now, ours is not gonna look that polished. Now, ours is probably gonna be more like, well, I guess the original Snake, that we have some grid and we're gonna have a snake and a pixel that's gonna be, I guess, the apple. Well, just to keep the scope of this video in under control, I did actually start recording this, or did start a previous recording of this, and for whatever reason, my Pygame window just, well, it either wouldn't open up or it took a really long time to open up. I'm not sure what happened. I did a Windows update now. I updated the graphics drivers and all, so we'll see if it works. So I should have Pygame, yes, still installed. All right, so we're gonna write the basic Pygame, well, game loop, so just pretty much boilerplate code. So we initialize the module, then we make our screen. That's gonna be a pygame.display.set mode, and we're gonna give it a width and a height. Now we're gonna be smart about this. In order to avoid having to deal with aspect ratios and all that, because I still want to have a square grid, I'm just gonna make the whole screen square. I mean, to be fair, it's also square here, so I guess there's not much lost there. So we'll make the width and the height both, I guess, 900 pixels. So 900. All right, so now we go on to the game loop. So we make a running variable, true. And while we are running, we poll for events. So for event in pygame.event.get, and we check if the event type is equal to the quit event. So we can close the window. And if it is, we set the running variable to false. So we break out of the loop, and once we're here, we do pygame.quit. All right, moment of truth. We'll see if the library works. Okay, so I think the Windows update and everything fixed it. So here we are, the basic empty Pygame window. Now, what I'll do is I'll limit the FPS, time clock, and in here we just say clock.tick and then 60 for the frame rate. I don't know, I'm still not trusting my computer now, so I'm not gonna overburden it by running this thing as fast as possible. And also, I think sooner or later it's gonna be good to limit the frame rate once we have a game set up. But okay, so this is the basic game loop. Now let's go on to our version. So yeah, as I said, we're gonna have some grid, and the stake on there is just gonna be, well, the grid cells colored in a certain color, and then we're gonna have the fruit, the apple, in a different color. So I think let's get started on the grid. Before we even implement any of the logic, let's try to draw like a grid on screen. Okay. Now I'm inclined to wrap this all in a class. So we do maybe the grid. So we're gonna take, I guess, a cell size, and by default, let's make it 90, because then I guess we're gonna have 10 cells. Yeah, I guess. So we're gonna have a 10 by 10 grid. So size is cell size. And I think we actually don't need much more. Yeah. So we're gonna also have to store the grid. So we do a self.grid. And I'm just gonna use a 2D array. Again, given that it's gonna be such a simple game, I don't think we have to worry about efficiency too much. So we do, I think I'm just gonna initialize all with 0 for now, all the grid cells, and I guess then we can display the snake as a 1 and maybe the apple as a 2 or something like that. So let's just do that. So 0 for underscore in range. And if we're giving a cell size, then I think we should determine, I guess, like a width and the oh no, not the width and the height, but how many cells we have. Cell, and what do we call this? I guess size is just going to be the width over the cell size. So in self.size, and the same for underscore in range self.size. And I think that should do it. I mean, let's try it out. So I'll make the grid. And we don't need to input anything. And how about I just instantly print out grid. So, okay, because that is interpreted as a float. Okay. Yeah, let's just put an int around it. I think floative would have also done the trick, but yeah. Okay, and yeah, we actually get a 2D array of all zeros here. Okay, looks good. Okay. So that's going to be what's going to hold all the logic. So I think at least my idea right now is to, again, as I said, have the snake and the apple just live as some number in here. And then just basically based on whatever number is on the grid, we color the cell differently. Yeah, so let's display the grid. So let's have a draw function, a self. And I guess you also need to know what screen you want to draw yourself. Yeah. Okay, so we do for, I guess, row in self.grid. So we're just going to loop over every cell and just draw a rectangle based on the value of the cell. And so for cell in row, do we need the indices? Oh, I guess we do. So let's do for I in self.size, and let's do with the integers. So the current cell is just going to be self.grid of, I think J and I should be the, if we're basically using it like matrix coordinates, but we'll figure it out in a second. So let's just get the value. So for now it's gonna be all zeros, but later on we're gonna populate the grid with some values. Yeah. And then let's do if value equals 0. Which for now is going to be true for all. We just draw a cell. So we do like a rectangle. Pygame dot draw rect onto the screen. That's why we pass it in as a function parameter. Color, make it like a dark red for now. All right, and the rectangle. Let's reformat that a bit. like this. So the rectangle is going to be a tuple of 4 values. So, and the top left corner of the cell should be I times self.cell size, and then the y coordinates are j times self.cell size. And the width and the height is again just the cell size. Okay. So, if we do this now in here, we do grid.draw. We draw it every iteration of the game loop. We now should see a white screen if I would pass in the screen here. Okay, but we don't, and that is with good reason. We need to flip the display. So, as many graphics libraries, I mean, I guess Pygame is based on SDL2. We need when we draw some graphics, they get stored in like a buffer, and then we need to flip the display to show what we've drawn. So we do pygame.display.flip. Oh yeah, it's not white, it's going to be dark red. Okay, so now we have these little cells here, and I think to make them a bit more visible, let's give them like an outline or something. I'll reformat that a bit here. Yeah, I guess something like this. How do we do this? I guess we give them like a thickness almost. Actually, what if I just have something like a dx here? Dx, and say make it, I don't know, 5 pixels for now. And we offset the x value by the x and the y value by the x. Okay, so now all are offset, but now we also basically subtract here in the width and the height of this. Okay, and we have our outlines. Now, okay, now we run into this issue of we have the outline on the left, but we don't have it on the right. I remember we had this issue with the what's it called, the Game of Life. How did I fix it there again? I'm not sure anymore. Wait, what if I subtract 2 times dx? Yeah, I think, yeah, okay, so now it's at least evenly uneven. I don't know if that makes sense, but now the edges are a bit less thicker, but the middle lines are all the same thickness. So I think that's a bit nicer. And instead of having it at 5 pixels, let's say it's a minimum of 2 pixels, but make it int of, say it's, I don't know, 5% of the cell size, so 0.05 times, oops, that's not what I wanted. What is that? What did I enter now? Okay. Sure. Times self.cell size. Because now I think if we change the cell size to not 90, but in here, let's double it, make it 180. Then these also scale, don't they? I mean, I guess let's not get bogged down with all the details. I think we have enough work ahead of us. The cells are visible. I think let's change so if it's 0, let's have some dark gray background. So make it have a gray is 20 25, 25, 25. Color is gray. Yeah, I think again it's good. It looks similar to a Game of Life, but yeah, I think that works well. Now what I'll do in here actually is in the beginning of the loop, we do screen.fill with black 000, because right now we're not erasing or before that we were not erasing the grid, but because nothing changes, we're drawing on top of it each time. I mean, I guess if we draw the entire grid each time, we don't even need to fill it, but oh well. So now we fill it. Still works. Okay, so and actually my idea would be to now have, I guess, the snake something like grid of 2 and 3 equals, set it to 1 and then 4 and maybe 5. So say we have a snake that's 3 pixels long. I want to be able to draw it. So in the draw function, yeah, let's pull this out and do if the value is 0, we do color is gray. And if value is 1, we do color is white. And I'll define white up here. So, and in here we just pass the color. All right. Grid object is not subscriptable. That's why, because I need to call .grid. You know, how about we call this maybe not grid, because I don't like. Let's call it a board, and the board can have a grid. And your board. So okay, maybe that's a bit more understand. Okay, so right here we have our snake, and that's basically my idea of how we're gonna visualize this, I guess. Yeah. So we just set the values of this grid. Okay. Let's try to implement the movement of the snake. So I guess I can make it a class as well. So let's have a snake in here. So what does the snake need to know? Well, I guess at the beginning, nothing, because we just start as a snake. I guess here it's also 3 pixels long. And then the growing is happening in the game loop. So I guess at initialization, we don't really need much. At least we don't need to give it anything. So but the snake, what it should know its, I guess its components. What do we call it? Like the individual pixels. What do we call it? The body? Let's call it the body. And that's just an empty array. And in here, in the body, we'll pass coordinates. We'll do like 2, 3, 3, 3, and oh no, what was it? 2, 4, and 2, 5 as tuples. And then those will act as these indices as the grid, so we know where we need to set it. I'm not sure if this is the best way of handling that, but I guess it's going to be good enough for us. So, let's actually leave this as our starting snake for now. So we initialize it with those values. So let's give the snake a way to interact with the boards. We do snake dot put on board, I guess, and we'll need to give it a board. So for j and I in self.body. So we extract those pairs. And then we do board of j of I equals 1. I think this should work. I guess so. All right, let's comment those out. And instead, we're gonna have a snake. Is just a snake. And I think I can just put it on the board with outside the loop. Put on board on the board. Because it's not moving right now, we don't need to update anything. And again, I need to call board.grid. Okay, I don't know why I keep forgetting this. Okay, and we did actually set the board correctly, because if I take this out, the board is empty again. Okay, so we have a way to draw our snake. Yeah, I think this is pretty good. Yeah. So let's get it to move. And you know what? For now, just to make the logic a bit, or like not have to worry about too much, let's just make our snake 1 pixel long, because then we only have to move a single pixel, and then we can worry about the rest later. Yeah, so let's try to implement this. So the snake, besides putting it on the board, we also need to, I guess, update body. So each frame, or each iteration of the game loop, we're gonna update the snake, because that's the main part of the game. Is let me just restore this to the regular mode. The main part of the snake game is that it moves without having to press anything, and this is what's going to be the challenge at some point. Is our snake is going to be that long that sooner or later we're going to run into our body, or I guess you can actually complete the game if you fill up the entire screen. So it should move regardless of user input. The user can only change the direction in which the snake moves. So let's give it a direction. So self.dir for direction is just gonna be, I guess, a tuple. Yeah, I guess so like velocity in x and the I guess then we shouldn't call it direction, it's called velocity, I guess. So, and in the beginning it should be 1 and 0. I guess I don't wanna mix the indices too much. So I guess right now we're using these matrix coordinates of. Wait, are we? Yes, we are of. So if we start counting at 0, so it's 0, 1, 2, and 0, 1, 2, 3, instead of, I guess, would be what more people know is the classical XY coordinate. So that's x equals 0, 1, 2, 3, and y 0, 1, 2. So let's actually also stay consistent with it. So that's so if I want to make snake move in x direction, well, I guess for you guys it should be like this. I should put it like this. I need to put it like this. Okay. So given this velocity, we need to update the body. So we do. I mean, I almost want to do something like this. For J, for. I mean, I guess now that you only have one, I can do something like this. The body of 0 equals of 0, so that we basically just add the velocity. 0, and here, let me just make it 1. So this would be I think this should work now for one. I don't think this is gonna be the way I'll do it, but let's just try it out. So we do snake.update body. And why are you not doing anything? Oh, because actually I need to because I need to clear the board after I draw it. So yeah, so because now but what I'm I mean, it should still actually fill up the board. I don't understand why it's not updating. I mean, I only wanted to kind of demonstrate is how to what the I guess the naive method would be for one pixel, and then I think I have a better idea for body. But now I'm curious as to why this doesn't work. Okay, so let's do maybe like something like this. Let's just do only one. Okay, and then print board.grid. Oh, because I don't. Wait, I don't actually put it on the board. So actually, I need to do it in here. So if I update the body of the snake, let's actually also input the board in here, and then do call after I've updated the body. Let's do self dot put on board, I guess. Up here on board. Okay, and now it worked because without this, it's snake is here. Oh, I guess now I don't even draw it on the board, but now it's updated because now we are at 0, 1, 2 and 0, 1, 2, 3, 4. So it worked. And if I actually put it into here, okay, that was really fast. Maybe let's limit the frame rate. So now our snake has movement, and I guess yeah, we need to clear the board after each yeah, after we do that. I'm starting to think this is maybe not the most ideal way of doing that. You know, how about instead of just having it interact with the board, let's have it like a separate object, because we're gonna run into some issues that if I clear the board, then I still want to draw the apple, but I've cleared the board, so I might also clear the apple. So what if we do something like this? The board doesn't need a grid. The board is just going to be our backdrop, just our backdrop. So we don't need a color, it should always be gray. So, and I think this should now, and we don't need the value here. So wait, so let's remove the snake for now. Okay, so the board is just an empty grid. So, and I guess what we could do is to have something like draw, instead of having like this draw, just have to break this out in a separate function. So def draw cell. And you're gonna ask for an I and the J again as matrix indices, so this J and I. And then we just draw this cell at those matrix indices. And then in here, and you also ask for a screen. And in here, I just call self.draw cell at on the screen at J and I, because then the snake can use this method. Okay, so we did a bit of refactoring already, like 10-15 minutes into the video. Oh, it's actually been 30. Oh well, I need to pick up the pace. Okay. Okay, so update the body, and instead of put on, actually we can have the put on board. We just do board.draw cell onto the screen. So I guess we're gonna ask for the screen at J and the I. Board onto the screen. You know what, how about I should be able to just make the whole thing like global variables. What if I just put it up here? And we just do the screen by default. You're just, well, the screen. And I think this should, then we don't need to pipe it in there because we only have one screen again. It's going to be a very simple application. On the board at J and I. So let's see snake.put on board onto the board, please. Oh yeah, because now I don't need to pass in the screen in here. Okay. Why do I not see the snake now? Oh, because the draw cell now also should ask for a color, because now I'm drawing it all gray. So a color in here, and I guess I'll pipe in the screen into here, and the color should just be, I guess, by default gray, and then we can still override it as we go along. Requires one position argument color. Where here? Make it white. Okay. And I still don't see the snake. Why is that? Oh, because wait, because I draw the board after. So let's put it into the game loop. Let's put it into here. All right. So this was a bit of a rough ride, but we're back, and I think this is a much better way of doing with that, because now I still access the board, but now I don't have to override any variable because the snake already knows its positions. So we don't need to put it into the grid again. So okay. And now if I in here do put snake.update body, and again I'll lower the frame rate to something like maybe 5. No. Okay, why did you put it in? Okay, so, and now we get a moving snake. So, you know what? Actually, one thing. Actually, it's too late. Okay, so this works well for one body, or one snake with a length of 1. I think the much smarter way would be to not actually move the actually wait, let me show you like this. So I'll go into the game. Let's disable the sound. It works a bit better if the snake has a bit of a length, But notice how the body parts of the snake don't really need to move. So all we care about, I know here it has a different width and different color and all, but basically all we care about is there a body part of the snake? Yes or no? No is gray, yes is white. So what we could do each frame is just basically, I guess, append a new body part at this new position, at this offset position, and just delete the last one. Because then we can also, it will also work for length that's greater than 1. So let's do that. So I'll go back to a length of 3 because right now this doesn't work. So now the head just takes off. So what we'll do in here is I'll make it so that the last, should I make it the last one? Make it so that the first index is the beginning of the head, or the beginning of the snake, that's the head, and the last one is the tail. So what we'll do is self.body, and we'll pop off the last one. I think, yeah, by default it removes the last one. So if I just do this, the snake at some point just dies. So there you go. And now to keep it alive, we need to just give it a new head at each, at each iteration of this. So we do self.body.insert at index 0, so before index 0, I guess, so in the beginning. And what do we give it, like a new head maybe? So in here, new head. And the new head is pretty much what we have before, so self.body of 0, and then the x coordinate and the y coordinate, and then we just add the velocity components in here. So I think this should work now. And yeah, there you go, the snake moves. So, because again, what we do each frame is I just delete this last one and give it a new one. Yeah? Okay, I actually don't know why in the beginning it has length of 2. Okay, we'll worry about that later. And now all the user input does is change the direction. But before that, what I want to do, in a lot of the snake games, I think in here you also can have that. Oh wow, there's so many more modes. I think, was it in the peaceful one? Yeah. Is that the snake just loops around. And I guess the only obstacle is yourself. And we can do this very easily with the modulo operation. So we update this. And I guess we'll do something like this will wrap it in parentheses and then do modulo. I guess then I need to know the cell size, or I guess the size of the board. You know, let's just make them global variables. You know, because again, it's going to be a simple application. They're not going to change. So let's do cell size is 90, and then we're going to have a board size, if that makes sense, is again just int of width over the, if I could spell, width over the cell size. All right, then you don't need these parameters. You don't need that. And I guess you don't need an initializer at all. Yeah. I guess, you know what, just again for simplicity, let's just keep it at this, and then so like this. Then I don't need to change the code too much. So, but I can access it here, and then we just do board size, and I think this should do it. Width. So board takes 2 arguments, but takes one position argument, but two were given. Oh, yeah, I guess you don't need a cell size. So, okay. And now I guess the snake should actually loop around. Yeah, there you go. Okay, so now let's implement the user movement, and I'll put the frame rate up to make it maybe 30. Because the thing is, then also Pygame reacts more slowly to our input. That's why I can't close the window. So let's keep the frame rate high, and we do only if. Oh, how do I? So we need something like an FPS counter. So we do frame, we have the 0th frame, and at the end we frame plus equals, or frame is frame plus 1, and again we take it modulo 60. I'm actually not sure if Pygame has an inbuilt like frame counter, probably does. If frame, say modulo 4, so every 4th frame we update it, make it maybe every 30th. Equals 0. Yeah, okay. So we can make it maybe 20. So now we still run at a high frame rate, so I can the window is responsive, but the snake is a bit slower. Okay. And now I guess all we need to do is make it interactable. So if I press a key, it should change this velocity of the snake. So in here, in the event loop, if event dot type is a pygame dot if it's a key down, if I press some key, then I first check what key I pressed. So we do event if event dot key. I think that's the right way to access it. Is pygame dot. Let's start with down, key down. Let's just print something and see if it works. So yeah, I'm pressing down key and it goes down. So if it's the down key, I want to change the snake velocity. Then we do snake.vel equals, and well, what should it be? If that is the y component, it should be 1 and 0, I think. Yeah, because again, we use these matrix components where going down in the first entry is the equivalent of going down in the y direction. So I guess, and what we need to do now is just copy this 4 times. So, and we do elifs here. If it's up, if it's right, and if it's left. So up is just inverting this. Right is what we had by default, 0, 1, and left is then 0, negative 1. So now snake goes down, snake goes left, and snake goes up. Wonderful. I'll make it maybe a bit faster, make it 50 maybe in here. Now, one issue we have is right now we can turn our snake around, just like this, which shouldn't happen. I mean, first off, it should die because it runs into itself. But in here, you actually can't do that. So right now, for example, I'm pressing. I don't know why the sound is always on. It's so loud. So right now, as you can hear, I'm pressing the left key, but it's not turning around. So I guess we should input a check in here. Key down and snake.val is not equal to, I guess basically it's inverse. So, and to make it a bit better, let's actually put them also into some variable names. So up is, as I said, -1, no. Yeah, -1, 0. Down is 1, 0. Left, oh yeah, left is 0, -1, and right is 0, 1. So if the snake velocity is not up, we can set the velocity to down. If the snake velocity is not down, I can set it to up. So that's just to prevent these 180s. Is not left, I can make it right. And if, no wait, and snake val is not equals to right, I can turn left. So this should now prevent, yeah, I can't turn around anymore. But I can still turn in every other direction. Oh, wait, why could I? Oh, I guess if you're fast enough. So what I can still turn around if between the frames where it gets updated, if I set the velocity to, say I'm going down, I quickly set it to right and then quickly press up again. The velocity was already set to right, so I can turn back up. You know what? We're not gonna worry about that. Again, just for conciseness, I guess you can cheat in my game, but it won't actually do you much good because you'll die, because that's the next thing we'll implement, is checking if the snake is, well, overlapping with itself. Def check overlap here in the snake itself. Now, is there a way in Python to check? Oh, I think yes, there is. Can I not do something like for pos, or yeah, for pos in self.body, if, because I think, yeah, we have a count method, and if I pass in the body, the position, then it should give me like the count how many of those we have. Let's just print that for now. See if I'm correct about that. Snake dot check overlap. So in here, yeah, okay. So we have 1, 1, 1, and if I duplicate some value, and I can even move it around, yeah, then we have 2 of, well, the first entry of 2, 3, because it's twice. And then we do, I'll just stop that. If that count is greater than 1, we first we can break. And yeah, I guess then the game is over. So we do self.body. How about we just clear it and print you lost. How about that? And I'll make the snake a bit longer so I can crash myself. So there is my snake. And if I... Okay. Why is it not doing anything? I mean, I am clearly overlapping, aren't I? But But it worked before, didn't it? What if I just print the body of the snake each? Oh, wait, actually, I need to check the overlap. Hold up, I need to check the overlap. So we update the body and then we also check the overlap. Wait, do I need to... Wait, is the issue that I'm basically going the wrong way? That's what... Yeah, it instantly kills it. Okay. So now I should be able to kill myself. Yes, okay. Yeah. And okay, I guess then because I delete the body, the whole thing crashes. Okay, so what if we have something like a snake has an attribute self.alive is true. If we crash, we can break and we do self.alive is false. And I guess we only need to do that and snake.alive. So now if I crash myself, the whole thing just stops and you lost. And you need to start again. Okay. So if I crash myself, I lost. Okay. Then I guess there is only one more thing to add. That's the growth mechanic. So again, every time we eat an apple, our snake grows by 1 pixel. Yeah, so let's... So where do we do it? So we draw the board first. So we need an apple. You know, let's just for consistency's sake make it also a class. So class apple. And I guess you should know your j and your I index. Self.j is j and self.I is I. Yeah. And then we should be able to draw the apple. So draw self. And you just do I guess onto like, you know, to know onto which board, right? Yeah. Draw, or I guess also called put on board. Put on board. Board dot draw cell at j and I. And the color, let's make it red. So let's have a red color in here. And red of self.j and self.I. Okay, so we have a snake, we have an apple, and then in here I'll do apple.draw, no, put on board, and let's have the apple at 5, 5. So we need to give it the board. Actually, wait, good question. Why don't you need the... Oh, actually, no, you don't, because I put it up on the bottom of here. Okay, that's fine. Yeah, okay, and there's our apple. Right now... Oh, I lost again. I really need to fix this mechanic where I can just do this and quickly turn, I don't know, down and then turn around again. Let's implement the apple mechanic first, and then if this doesn't take us too long, then we can still fix it. Okay, so right now I just pass through the apple, nothing happens. So we do something like on the apple, def check snake collision, or check eaten. self with a snake. So if snake, wait, can't I do? No, let's make it simple. So for pos in snake.body, so basically just check if it's overlapping. So if pos equals to self.j and self.I, basically just pack this whole thing into tuples so I can compare tuples, right? I know for lists it doesn't like it, but I think I can we'll see. Oh yes, I can, because I did it down here. So okay. So if it's same position, then well, what should happen then? I guess the apple should kind of, well, disappear and reappear at a new position. So we do self.j equals, and I guess we need the random module now. So import random. So it should reappear at a random position. Is random.randint from 0 to the board size, and the same for the I. Okay, let's see if that works. So if I'm at the, I need to call them. I always forget to call the methods. I always write them, but then I forget to do that. So we update the body, we check the overlap, and then we do apple.checkeaten in here of the snake. Right. And yeah, it reappears at the new position. Okay. Now our snake is not getting any longer from this. How do we handle that? Well, I guess I should increase my, or like what should happen then, I guess, if we're doing it with this deleting and inserting a new element, is I shouldn't delete the last element, because that's the equivalent of growing one, is if I move my head forward, but I don't delete the last element. So what if we do in here, apple eaten is per default false, and I only delete if apple eaten, if not apple eaten, if I haven't eaten an apple, then I delete the last part. And in here for the apple, wait, hold up, no, that doesn't really work. No, then maybe what you should do is, yeah, you set your position, then return true, as in signal, okay, yes, you've eaten something. And then you return true. And in here, what we'll do is, so wait, let me get the order of this right, so we don't mess up. So I update the body, say it moves on to the apple. I guess I check the overlap, whether I've killed myself or not, that's fine. Then eaten is the apple checks if it's been eaten by the snake. If the apple, you know, can't I just do this of and then I pass in the eaten parameter in here. Wait, are we getting longer? No, we're not, right? Oh, I lost. Wait, let me make this. Let me make the snake smaller again. So we're 2 pixels long. Yeah, no, we're 3 pixels. Okay, and 4. No, it works. Okay, it works. Why is the apple gone now? Okay, so it does work. Because basically what's happening now is I'm comparing it to the last frame. Basically. Yeah. So now I always draw the... Why is the apple disappearing after I've eaten it twice? That's interesting. Is it always after 2? I mean, maybe it's some... Is it like an edge case where the apple spawns inside the snake? Yeah, I guess, because what happens if... What happens if the apple spawns inside of me? I mean, it should work, right? I mean, we can try. What if I just set the apple to... What's our snake position? To 2 and 3. No, that works. Oh, wait, is it... because it should be board size -1, shouldn't it? Because I think random includes, yeah, both ends. But because we're starting, it's like a classic off by 1 error. We're starting to count at 1, and the board size is actually never reached, so we never have a 10th cell here. It's always at 9, so I think now it should work. So let's play around a bit. Okay, I mean, it hasn't disappeared so far. Yeah. Yeah, looks good. It's okay, and there's now this bug in here. I mean, but I think other than this maybe little annoying issue of I can turn around to myself, it's pretty much done. So let's just quickly fix that. I'll be honest, I'm not too, how should I say, proud of this code. It is a bit janky with well, update the body with the eaten and I think there are cleaner ways to do it in doing that. Also, let's initialize the apple at random positions. So we don't ask for an index anymore, but instead what we do is, I mean, basically the same thing we do down there, rand int from 0 to board size -1. Because now it's at a different spot each time we start. And let's put the snake like in the original onto the middle here. So that's 0, 1, 2, 3, 4, 5. So 5, 5, and positive x. 5, 4. Does this work? Oh, yep, put it. Okay, yeah. So and now we started on the middle of the screen. I guess with 10 cells there is no exact middle, but oh well, close enough. So how do we how do we fix that now with the, I can turn around. So again, the issue is I check this. Well, the issue is I check this every frame, but I update the position only every 15th frame. Can't I just wait? No, because it's in the for loop. No, but and frame modulo 15 equals 0. Can I just not do this? Okay, but now the issue is, see, I'm pressing right, for example, now. Now I need to actually hit it on the exact frame. That's not the fix. Okay, how about the snake doesn't only know its current velocity, but how about because I guess we need a way to how about we just buffer these velocities? So instead of we set the snake velocity, we just do new vel is that. And then only in here, every 15 frames, I do snake.vel equals the new velocity. And I think this should fix, oh, well, not. Oh, and the, and else, if I haven't, if neither of the keys are pressed, then new vel, no, I guess in here. So if no key was pressed, then new val is just equal to snake.val. Okay. So again, I'm pressing left now. I can't turn left. So, but oh, why can I? Oh, now I can't turn again. Oh, because I guess if I again now the issue is if I for a frame I don't press anything, now the velocity gets overwritten. Oh, how do we do this? Well, let's just have it at none. So the new velocity is not nothing. If I press the key, it does something. Then I give it like a new value, like it's buffered up. Is so if we have a new velocity, then we update. I know this is more like trial and error now than actually thinking about this. But okay, I can't turn around, so now I'm pressing right. Can I do the switcheroo now? If I'll quickly try to press up and then right. Okay. It doesn't seem to work. Okay. And I can still smoothly, or I guess fairly smoothly given the frame rate. Maybe let's increase that again every maybe 10th frame. Get a bit faster now, the snake. Yeah. Okay, so wait, let me just think through what we've did. So what we've done. I mean, I guess, wait, can I just set it to right and then I just always pick the new velocity, because I guess as long as it doesn't get overwritten. Yeah. Okay. Okay, so here is now how it works. We have a new velocity that's per default it's going to be right, because why not? And if I ever press a key, this new velocity gets updated. That sets the velocity of the snake. I know we're just now kind of, again, buffering it or holding it in snake.val for, I guess, almost no reason, because I could just put it here in the update body, just pass in the velocity, but yeah, okay. As per usual with these projects I do on this channel, there is a lot you can optimize in here. But, I guess all in all, it does work, and also surprisingly well. Now, again, without having this issue of I can just crash into myself if I'm just too quick with the keys. So actually, let's see. Again, as I always say, there's 1,000. Oh, and now I've died. There's 1,000 things you could improve on that. You could maybe have some text appear in here and stuff in the console of just you lost and the game pauses, and maybe a restart button and all that. But I think let's not make this video too long. We've achieved our goal. We've made Snake in Python. It has all the defining features of the Snake. It's not as polished as the original. I guess one thing that would really help is to, I guess, be able to queue up almost like 2 moves, because for example, if I want to do something like this, that I try to move up just 1 pixel in this direction. Right now it's a bit difficult, because if I press it too quickly, then the second input just gets eaten. So I guess there are ways to also register that, and then say, okay, first turn up, and then next, I guess, iteration, when you update yourself, turn left or turn right or whatever. Again, I'm not gonna do this. I'm very happy with this project, and yeah, as per usual, thank you guys for watching, and see you in the next one.